Okay, so we're going to be using the squeeze theorem to evaluate a function. And so first let's go over what the squeeze theorem is and what it says. So the squeeze theorem holds that when you let f, g, and h be functions satisfying this inequality for all values of x in some open interval containing the number c, then if g and h have the same limit as x approaches c, then f also has this same limit, which is shown here. It's pretty easy to understand. So let's evaluate the limit as x approaches 0 of x sine of 1 over x. So to start off, we know that the sine function, its asymptotes, you could say, never go above or below 1 or negative 1. So you can start your inequality as negative 1 less than or equal to sine of the argument, which is 1 over x, which is less than or equal to 1. And what you're missing is the x right here. So to put that into the inequality, you multiply each part of the inequality by x. And when you multiply by a variable, you want to put absolute value bars around the x so that you don't have to change the inequality and change the sign. So when you get to here, it's less than or equal to 1. So per the squeeze theorem, if the limit of both sides of this, both sides of this inequality, if they equal the same, then the limit as x approaches 0 of x sine 1 over x will equal that limit. So now you take the limit as x approaches 0 of both sides of the inequality. So it's negative absolute value of x, and the limit as x approaches 0 of the absolute value of x. And both of these you get 0 when you plug in 0 as to the variable. So therefore, by squeeze theorem, the limit as x approaches 0 of x sine 1 over x equals 0.